Okay, so I gave you a handout. We'll talk about this handout in just a little while. First, there are some questions over the homework. Miguel, you had asked me. Number 27. This is 6t squared plus 7t minus 5? Okay. So number 27 out of the homework. 6t squared plus 7t minus 5. Now let me ask you right off to start this. Is your problem that it didn't match what the back of the book had? Or is it no? Okay. Okay, so let's do this the way that we did it in class, all right? Which was, you look at it, first thing you look at is GCF. Oh, you know what? Let's go ahead and start using this thing I handed out to you. You're allowed to have this on the test, okay? And then additionally, you can also have another sheet with, you know, anything, you know what I mean, the stuff we normally have. So look in the bottom. This has a summary of a lot of things from 0302 that we've done, formulas and things like that. But the bottom left-hand side of this page says the general factoring strategy, right? So what is the first step here? Factor out the GCF. So we look at this. Do we see a GCF? No. All right, step 2. If there are 4 terms, try to factor by grouping. 1, 2, 3. Okay. If there are 2 terms, well, it's not 2. If there are 3 terms, what does it say? Use the AC method to factor. Now, the AC method is that method that I was showing you with the little X and everything else. It's a version of the AC method. So I'm going to do that, AC method. I take my 6, I take my negative 5, I multiply them, that gives me negative 30, right? I take the number in the middle, or the middle term, and that's 7. And I try and come up with 2 numbers that multiply to be negative 30 and add up to be 7. So I'm going to list out all the factors of 30 here. I always start with 1. 1 times 30. I'll look at these as I go. There's no way I can put 1 and 30 together and get a 7, right? So I look at 2, 2 and 15. Can you put 2 and 15 together to get 7? No. 3 and 10? Okay, now 3 and 10 will get 7, but what I have to have is a positive 7, which means I need to take positive 10 and subtract 3, right? Let me just throw that up there and see if that works. Positive 10 minus 3. Now, does this work? 10 times negative 3 is negative 30. 10 take away 3 is 7. Okay. Now, let's do what we did in class. I'm going to show you something a little different today, not to confuse you, but we're talking with several students in this class and in other classes. There's another approach that some students liked when I showed it to them, so I want to show it to you also, all right? But let's just finish this off the way we did it last class. I said you put 2 sets of parentheses, right? You put your numbers 10, negative 3. You put your variable, in this case I don't put x, right? I put t, positive 10, right? I leave a space in front of each of them, and now I decide what I'm going to do with the 6, right? So I can put the 6, I have to put the 6 underneath one of these numbers, right? Neither one of them will give me a whole number, right? 10 divided by 6 is not a whole number. 3 divided by 6 is not a whole number. So I just have to choose one or the other. So which one do you want to go with here? You want to go under the 3? That's fine. So 6 in front of the t on the left factor, and then underneath the 3. So I put my 6 here. I put my 6 here. And that gives me 6t plus 10 t minus 1/3. 1/2, yes, thank you. Right? Now look at your steps for factoring. Look at step 5. Examine the answer to be certain you cannot factor any further. Can I factor any further? The 6t plus 10 has a GCF in it, doesn't it? Okay, so what can I factor out of that one? A 2. So I pull a 2 out. I'm left with 3t plus 5, t minus 1/2. Now, you can box this answer and be done. That's not wrong, okay? Or you can, if you're going to try and match it with the back of the book, this 2 here, we took it out of the first term, didn't we? We can actually put that term back into this one. Why would I want to do that? Because 2 times the half will get rid of the fraction, won't it? So I'm just going to show you that can be done. Again, you wouldn't have to do it, but if you're looking to match the book, this is what you would do. Multiply the 2 just through the second one, not through the first one. You get 3t plus 5, and then 2t minus 1. Now that would match the back of the book. Okay? Yes. The 2 does not, are you saying the 2 doesn't go through here? It just stays, Yeah, this can be a little tricky, so let me try and explain what's happening. What we have here at this stage, I have in the yellow there, I have something, and then the green is something else, and the blue is something else. Those are 3 things being multiplied, right? So let me, on the side here, put 3 numbers. 3 times 4 times 5, okay? If I asked you to multiply, this is 3 things, right, being multiplied. If I ask you to multiply 3 times 4 times 5, you don't do 3 times 4 and then 3 times 5, right? What you do is 3 times 4 first, 12 times 5. Or you could do 3 times 5, which is 15, then times 4. You understand? So what we did with that 2 out front is we took it out of this one, right? We brought it out here, and then we said, we're going to put it back into this one. Now, go ahead. Yeah, if you multiply 2 right back in here, you'll be right back where you started. So you'll still have a GCF, so it won't be factored all the way. Okay, now let me show you the slight change on this problem that, like I said, some students in my last class were like, no, I'll stick to what you showed me. And the other students were like, no, I like that. I'm going to go with that. Okay, was there a question?
Yes, I have a question. So we don't multiply the GCF to the first parentheses?
That's right, because that's where we got it from, right? Okay. We took it out of the first one. Gotcha. So then we're going to put it back in. The only reason I'm putting it back in the second one is because this one has a fraction in it. Okay? I have a feeling y'all are going to like what I'm about to show you more, which makes me feel bad because... No. Plus 17. Yes. Yep. All right, so here's the same exact problem. The good news is everything's the same as far as how you do this up until one point, all right? So we still do, okay, is there a GCF? No. How many terms are there? 3. Okay, we go AC method. 6 times -5, that's still the same. We get -30. We still look at the number 7. That's all the same, okay? We think about the numbers. We make our little table. We figured out 10 and -3, right? So all that's the same from what we just did. Here's where the difference is. You don't do the set of parentheses. All right, here's what you do. You write out the first term, 6t squared. You write out the last term, -5. But this middle term, plus 7t, right? What we're going to do is we're going to be very clever, and we're going to use the 2 numbers we just found, 10 and -3, to rewrite positive 7t. And the way we'll do it is this. We'll put, it was a positive 10, right? I'll put positive 10t. Notice I put t there. And then I'm going to use the -3, so I'm putting minus 3t here. Does everyone agree that 10t take away 3t is still 7t? So it's just a clever way of rewriting the problem, isn't it? The only way I would have known to rewrite 7 as these 2 is by making this little table over here, right? Understand? But what I have done here is I've taken a problem that started with 3 terms and I've turned it into a problem with 4 terms, haven't I? And because it's 4 terms, how do we factor 4 terms? Grouping. So I split it right after the 10t, right? Split it right there. I look at the first 2 terms and I try and pull a GCF just out of the first 2. 2t. What's left? 3t plus just 5, right? because you already have a t there. Now with grouping, remember what we did is we said, okay, we want to match that, 3t plus 5. So we put it over here and we said, okay, I want to try and figure out, is there a number I can put in front of this that when it multiplies through, I get back what's up here? -1, right? -1? Just a quick check of that. What's -1 times 3t? -3t, which is this. What's -1 times +5? -5. That does work then, doesn't it? And then what we said with grouping is that if these two things match, right, then what you'll do is you'll write it down in parentheses, right? And then you'll write another set of parentheses, and what goes in there? Those two things that were in front, 2t and -1, which gives you 2t minus 1. And that matches the answer that we just got. Yes? Is that what they showed you? So, okay, so let's do a little quick vote. I know I've only given you one example, but what do y'all think about this? How many of you think that you might be leaning in this direction? Huh? Don't be shy. You're not going to offend anyone. It's just math. All right, you got to find what works for you is what you got to find. You know, I'm not a big fan of showing everyone like 5 different ways of doing it, and you find the one that you like. I can only show you maybe 2 or 3, and at that point, I think it starts to be counterproductive. You have too many ways to do a problem. All right, any other questions on the homework? Okay, which one? 35? 33 and 35? All right, let's do 33. 6b squared minus 11b plus 3. All right, I'm going to do this both ways. All right, I'm going to do it the way we did it last class, and then I'm going to do it the way I just showed it. All right, so first thing, is there a GCF? No. How many terms? 3. Okay, so since it's 3, we're going to do AC method. We're going to do that times that, which is what? 18, and then the number here? Negative 11, right? No, that's all right. By the way, before I go any further, when you have 3 terms, what method are you supposed to use? What does it say on that sheet? AC method? Okay, everything I've shown you, you know how I've shown you a couple of ways of doing this now? They're both called AC method, but one of them's like the modified AC method, and then the other one's called the AC method with grouping, and then there's like all these different names for AC method. I know. But what I'm getting at is when someone says, oh yeah, factor using AC method, it's very general. There's lots of ways to do that. But they all have something in common. The thing that's in common with all the techniques is that you have to come up with some numbers. That's going to happen no matter what. You're either going to do that in your head or you're going to do that on, writing it down. So let's see if I can come up with these numbers. I need 18 here. So 1 and 18, can I put 1 and 18 together to get an 11? No? 2 and 9? That looks good, right? I got to get the signs right. I need a negative 11, so what? They both have to be negative. Like, oh, I'm not going to do it down there. -2, -9. Now let's just double check it. -2 times -9 is +18. And then when you add those up, 2 negatives stay negative when you add them, right? So -11. That works. So what I'll do now is I'll write 2 sets of parentheses. I'll put a -2, a -9. I'll put B. And then the number I'm going to put underneath is what? 6. And I'm going to put it, well, nothing's nice there. Where do you want it? Under the 2? We'll do it under the 2 this time. Under the 2, and then in front of the other B, right? So we have B minus what? 1/3. And then 6B minus 9. All right, can we pull a GCF out of either one? A 3 out of that one, right? That 3, I'm going to pull it all the way out to the front, in front of everything. Is that all right? 2B minus 3, right? When I pull a 3 out of 6, I have 2 left. When I pull 3 out of 9, I get 3. Anything? I mean, that we said we could box that and be happy, but You can get rid of that fraction if you don't like it by trying and multiply that 3 back through. So if I multiply 3 back through, I get what? 3b minus 1, and then 2b minus 3. So I guess what you could maybe argue is that this way is maybe a little faster in the beginning part, but then if you have to deal with the GCF, it gets there's a little more complication to it. The other way, you're going to have to do the 4 terms. You're going to have to split it. You're going to have to pull GCF. You're going to have to match it. But when you're done, you don't have to do any more work. Like it should be done. So they both have pros and cons. Let's do it the other way, all right? What I'll do is I'll rewrite the problem here. All right, so we did the same thing. We get our 18, we get our negative 11. We found negative, how did I write it up here? Negative 2, negative 9? Would it have mattered if I put negative 9, negative 2? No. Okay, so the other method, we pull the 2 ends of this thing down, right? But the middle, I use these 2 numbers. So what will I write in the middle here? Negative 2 what? B. Don't forget, it's got to have the B there, right? Then minus 9b. And just double check, negative 2b take away 9b is negative 11b. That matches what's up here. 4 terms, split it. GCF out of the first one. What? 2b. You're left with 3b minus 1. Good. Remember, we don't, to turn it 2b into 2b, we don't need anything except it's a negative, right? So minus, and then to make it 2b still, we just put a 1 there. You have to account for the 1 though, remember? Okay, and then we want to match that, right? So 3b minus 1 over here. And now, how can I make this 3b become a negative 9b? Multiply it by negative 3. Does that work? Negative 3 times 3b is negative 9b. Negative 3 times negative 1 is positive 3. So it works. So I can rewrite this as whatever they had in common, the 3b minus 1, and then inside that, 2b minus 3. We're there. It's funny, every time I teach this topic, well, maybe it's not funny, but every time I teach this topic, if I do it this way, if this is the first way I show students, I'll always have some students in the class that are like, well, I was shown a different way where you just put the numbers here and you do this thing. And I'm like, yeah, well, you can do it that way. And I wind up having to show the whole class that. And then if I do the other way, then I wind up having to show this. No matter what, I have to do them both, it seems, because everyone's learned different ways. And here's my opinion on it. I think you should know how to do both. And I think that you should have a favorite, but you should have a backup. You know, that's the way it should work. You should know that there's multiple ways of doing this, and every problem is kind of suited. You know, it'll work out sometimes easier this way than it will the other. What would have made this easier the other way is had, let's say we got, not this one, this way up here that we did. What would have made this a lot nicer, I think you could argue, is let's say if that number out here would have been, let's say, a 2, right, the 6? Because then you would have put the 2 under 2, and it would have been a 1, and you would have been done, right? Of course, if I change that to 2, then that changes that, and the whole problem changes. But what I'm saying is we did do some problems last class where when we put the number underneath, it reduced to a nice number. So then there isn't all this weird fraction stuff that we have to deal with later. You follow me? Okay. All right, there was one more someone asked about. 35, this will be the last one I do because we do need to move on. Number 35, 12y squared. Anybody need the handout that I put on the table? Is there copies? Can Can you hand those back over there? 7, wait a minute. Yeah, plus 17y plus 6. Do you know who that person was that went there? Okay, yeah, it was her. All right, just curious. All right. First step, GCF. There is none, right? Second step, there's 3 terms, right? So it's AC method. So I look at this, I go 12 times 6, 72. The number here, 17, right? All right, so now I'm going to start listing out factors of 72. 1 and 72, that going to work? No. 2 and 36, no. What am I trying to get? 17. All right, 3 and 24, getting closer, right? Because if I subtract these, I get a 21, so I'm getting closer to 17. 4, does 4 go in there? 4 and 18. Ooh, that's not going to work, is it? 5 go in there? 6 and 12. Oh man, that's close, right? 18. How about 7? No? 8 and 9. Oh, 8 plus 9 is 17. Okay, so look, it looks like these are going to work, right? Let's just make sure we get the signs right. We need a positive 17. That means they both need to be positive. I just got to hope when I multiply them, I get 72, which I do, right? So 8 and 9 work. All right. So we'll do it both ways. What I'll try and do is I'll just split my page here into 2. I'll try and cram them in here. If I do it the original way that I showed you, plus 8, plus 9, y and y, right, not x, and 12. And again, 12 doesn't go into 8, 12 doesn't go into 9, so I'm just going to pick one. I'm going to put 12 out front and 12 underneath the 9. This gives me 12y plus 8, and then y plus 3 goes into 3 9 times. 3 goes into 9 3 times. 3 goes into 12 4 times, so that's 3/4. So I could not leave this as an answer, right? Why? Because I have a GCF here. What's a GCF out of the first one? A 4, a 2, but you have to pull, yeah, the greatest one. So 4 would come. You would have what, 3y plus 2? And can we use that 4? We could pass that 4 through the second parentheses. 3y plus 2. What would I get if I multiply 4 through the second parentheses? 4y plus 3. See it? Now let's do it the other way. The other way, where do I start? Assuming we did all this already, what would I write down now? So the 2 ends, right? The 2 ends, write them down. 12y squared, and then I put my plus 6 over there at the end, right? In the middle, plus 8y plus 9y, right? 9y. Because you're adding these together. These have to be like terms, right? In order for that to add up to be 17y, they both have to have y's in them. Okay? Now, split it. What can you factor out of the first one? 4y. What's left? 3y plus 2. I need to match that over here, 3y plus 2. And how can I get my 3y to become a 9y, my 2 to become a 6? Just multiply by 3, right? And 3 times that will give me that. 3 times 2 will give me 6, so that should work. So a plus 3, right? And that means that I will have my my factor that matches, 3y plus 2, and then 4y plus 3. Well, it'll depend on you. I'll be very honest with you here. I personally think that for a student in this class, I like this way, okay? Because it forces you to do grouping over and over and over, which is a good skill to practice. This is the way that I would do it if I were doing this problem, right? But I would probably do it mentally. You know what I'm saying? Like I would do it mentally in my head. This one's better for you. See, and that's the thing. Everyone works different. So, yeah. So it depends. Here's also something we need to take into consideration. On the test, I would like to see your work, okay? I'd like to see this stuff because if you are going to do it mentally and it's wrong, you know? But if you go through this process here, and let's say right here you accidentally put -3 and then it changes that to a -3 right here, I can see that you understood most of it and I won't take off the whole thing, you know? So the more you show me on the test, the better for you. If you make a mistake, if it's right, then it's right. You know what I'm saying? Okay, well, we have to move on because we are supposed to eventually have a test in here again at some point. Let me look at our schedule. Next Thursday is what it was scheduled for, right? I'm just feeling like Thursday we won't be ready because there's still more we need to do. So let's make it official that I am going to push exam 3 to Tuesday, April 15th. All right? Because we just finished 6.4. We're actually supposed to be doing, is that right? We're supposed to be doing a review of factoring right now. So there's 2 sections we haven't covered. All right, we are going to start 6.5 today, I believe. Yeah, 6.5. So we're skipping 6.4. We're going straight to 6.5. Excuse me? 6.5 is called General Factoring Strategy. Well, on the handout that I just gave you, the bottom left corner says General Factoring Strategy, right? That's all this is, all right? This section is about giving you this set of steps and applying them. What you're going to see is that our problems are going to change, all right? So let's take a look at what I'm talking about here by doing an example. First example in this general factoring strategy. We're going to try and factor 3x to the 4th minus 12x cubed plus 12x squared. Now the problems that you're seeing right now, just so you know, are exam type problems, all right? What we've done up to this point is stuff you probably wouldn't see on the exam because as we work through this, you will see that this problem is going to require that we do what we were doing the last 2 or 3 days. So everything we've been doing up to this point is kind of building up to this now, all right? So let's take a look at this. And the first thing I do in the general factoring strategy is a GCF. So you look at all the terms, and nothing we've had recently has had a GCF, right? Now we do. Numbers, 3, 12, 12. So there's a 3 common to all those, right? So I have a GCF of 3. What else? I have x to the 2nd power. Remember how we did the x's? You looked at them and you, whatever they all had in common. So x squared. Anything else? Should I make it a negative 3? No, because that first term right there is positive. If it had been negative 3, then yes, I would have thought about pulling a negative 3 out. But I'll just leave it. So let's go ahead and do that. 3x squared. Set of parentheses. I need enough space in that parentheses to fit how many terms in there? 3, right? Because I started with 3, I've got to end with 3 in the parentheses. How do I turn 3x squared into 3x to the 4th? I only need an x squared, don't I? All right. How do I turn 3 into negative 12? Negative 4. And then how about x's? I need 1x there. How do I turn 3 into 12? Positive 4. Do I need any x's? No. Right? Put an equal sign here in front of this. Okay, that's where I am so far. So look at your general factoring strategy. We just did the GCF, right? All right. What is left inside this parentheses has how many terms? 3. So on what's left in the parentheses, I need to do an AC method on that. Okay? Just on what's in here. So let's take a look at the number that's out front. What's the number out front? 1, right? So I'm ignoring my GCF now because my GCF is outside the parentheses. I'm just looking in here. I take that 1, I multiply it times the 4, and that gives me my 4. And then I need inside this x here, down the bottom, negative 4, right? So let's put together our little factors of 4. I have 1 and 4 and what? 2 and 2. Those are the only factors of 4, right? 1 and 4, 2 and 2. How can I get negative 4 out of these? The 2's, right? But I need to make them both negative. So negative 2, negative 2. Just double check it real quick. It works, right? That works. Okay, now this is an example of a problem where you definitely would not want to do grouping because it's kind of a waste of time. You'll see what I mean here. If you do the fast way, well, the fast way that I showed you, right? You do 2 sets of parentheses. You put the 2 numbers inside, right? Negative 2, negative 2. You put what variable in front? X, X. You leave a space. And then you bring down what number? What number is it that you're going to try and bring down here? A 1. But that's not going to change anything, right? I put a 1 here and a 1 underneath here. Nothing changes. So it stays. You see how that would be so much faster than grouping? Because I'm done at this point. Now, I will put the 1 there just so it's on the video. Okay, that's what I actually did. You could do that in your head and say, really, nothing happens. So now I'm just going to take it away because I don't want it to confuse you. Now, move on to the next step of general factoring strategy, which would be number 5. Examine the answer. I have 3 factors, don't I? This GCF can't be broken down anymore. This one right here has how many terms in it? 2 terms, right? The only way we can handle 2 terms, go back to what happens if you have 2 terms. Are they a special binomial? So is it, when you have 2 terms, remember we had difference of squares, sum of cubes, difference of cubes? And they're on the bottom of this page, right? Is x minus 2 a difference of squares? No, x and 2 are not squared. So I don't have to do anything there, right? X minus 2 over here is the same thing, isn't it? So I don't have to break those down. I'm pointing that out because problems that we do as we continue, this might turn out to be something that we can continue to break down. So I'm done. I can box that as an answer, but you might agree with me that this is the same as this. Yeah. Isn't x minus 2 times x minus 2 something times itself? Which means it's x minus 2 squared. I would accept the first answer, but if you put this answer on your test, I would smile. that would make me happy. Because it means that you recognize that those two are the same and that you can condense it down to a little bit of a tighter format answer. I might even do +1 or something like that, depending on my mood, I guess. Okay, questions? We all right? All right, let's try something a little different. It's going to look bad, all right? It's going to look real bad when I put this up here. X to the 6th, y to the 4th, minus 27 x cubed y to the 4th. First thing I look at is GCF. So let me start with numbers. Is there a number that goes into, well, I have a 1 out there, so 1 and 20, the only common factor of 1 and 27 is 1, so we don't even consider it. How about x's? I can have an x cubed that can come out, right? So my GCF is an x cubed. And how many y's? Y to the 4th? Anything else? No. Okay, so x cubed y to the 4th is my GCF. I set a parentheses with enough space for how many terms? 2. 2. So how can I turn x cubed into x to the 6th? That would give us 2x cubed. You have to have, you want to add the exponents. So x cubed, right? X cubed times x cubed is x to the 6th, because you add the exponents, 3 plus 3. How about y to the 4th? Well, I already have it, right? So I could put a 1 there, but I don't need it because I already have the x cubed. All right, now how do I turn x cubed y to the 4th into, let's see, negative 27? Well, I need the negative 27, right? Do I need anything else? No, because I already have x cubed. I already have y to the 4th, so I don't need to switch anything. But I do need the negative 27. That okay? All right, so we pulled the GCF. Now what we do is we look inside the parentheses. We go, can I do anything with that? How many terms? 2, right? And it's a difference, and it's a cube. And wait a minute, 27 is 3 cubed, isn't it? So I'll do this on the side here because we might need to go back and remember this. X cubed minus 27 is the same as x cubed. Well, the way I did it in class is I said, we need to look at it as, can we rewrite it as 2 things being cubed, right? So x cubed is obviously, hopefully obviously, x being cubed. And 27 is what being cubed? 3. So in the formula, our a is x and our b is 3, isn't it? And the formula is on this sheet. It's the difference of cubes formula, which says that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared, right? That's the formula. So what I need to do is I need to rewrite this parentheses, everything in here, using that formula right there, leaving my GCF out front. X cubed y to the 4th. I'll have a small set of parentheses, then a larger set of parentheses, right? This is for my 2 terms. This is for my 3 terms. 2 terms, 3 terms. What's a minus b? X minus 3. Okay? Now the next piece of this is a squared, which for us is just x squared. And then plus a times b, plus x times 3, which is the same as 3 times x. So plus 3x. And finally, plus b squared, so plus 3 squared. 3 squared is 9. All right. Questions? We're not done. We need to talk about this still. All right. The GCF I can't do anything with. The second factor here has two terms, but it's not a square or cube, right? How many terms here? 3. So what do you start thinking? What do you start thinking with AC method? But I told you in class when we were covering this formula, and at that time you probably couldn't see the forest through the trees, so to speak. I told you that when you use this formula, you can be guaranteed that these 3 terms will not factor. It's prime. Remember the whole idea of prime? So when you use the difference of cubes formula or sum of cubes formula, you'll always get a trinomial over here. You do not have to do AC method on that trinomial because it is prime and you're guaranteed. Let me just show you. You wouldn't have to do this on tests or anything. Let me just show you it's prime. The 2 numbers I would have in here are what? 9 and 3, right? And now you write down all the factors of 9, which are 1 and 9 and 3 and 3, right? There's no way you can put these together to get a 3. So you're not going to be able to do it, so it's prime, so this doesn't factor, so you're done. There's no GCF here. Not in all 3 terms. There's a GCF in these 2, but not all 3. Okay? So just remember that. Anytime you apply the difference of cubes formula or sum of cubes formula, you do not have to factor the trinomial that's left at the end. Okay? You do not put prime because all you're saying is that this is prime, right? But you did factor the original problem. This is the factorization. This is the answer. The whole thing boxed. We've done one kind of like this one. 80 minus 5x to the 4th. First step is GCF, right? What's our GCF here? Just a 5, right? Enough space in the parentheses for 2 terms. 5 times what gives you 80? 16. Yeah. Then what? Minus x to the 4th, right? Okay, so we've done GCF. So we look at what's left, which is the stuff that's in the parentheses. And how many terms? 2. And it looks like a difference, right? Is it a difference of squares, difference of cubes? Well, nothing is squared, so to speak, right? But we did a problem like this before. 16 is actually 4 squared, isn't it? And x to the 4th is x squared squared. This is tricky. So let me rewrite this over here. 16 minus x to the 4th is the same as, or can I write it as something squared minus something squared? We said 16 is 4 squared, right? And we said x to the 4th is x squared squared. So we have to do faculty evaluations. Like every faculty member gets evaluated, and there's a process. There's somebody goes to your classroom and sits in on your class, and then somebody looks at your teaching materials, and then someone does something else, and then that group gets together, and after they've all looked at all your stuff, and you sit down with them, and they tell you, you know, good job or not good job or whatever, right? So yesterday I had to do a faculty evaluation sitting in the classroom for a government teacher, right? Man, I haven't been in government class in, since I was in college. And I was sitting there and I was just thinking to myself, God, this is what my students have to sit through. Like not, I mean, like I was thinking about what you feel like in here, you know? I haven't been in school in so long, and the last time that I was in school, it was graduate school, and when you're in graduate school, you live it. You live what you're learning, so you're excited to get up. You want to go to school. You want to learn, you know? In general, this general sort of education, you sit through these because you have to, because it has to be on your degree plan, right? You're not here because you love math. So sitting in government, it's like government to me is not something that I enjoy. So I was like, man, I need to have a little more compassion for my students, you know? I need to like get them doing more group work so that they stay awake, because I was like looking at the clock and, you know. She did a great job too. I mean, she was energetic, she was excited, you know. There were students who were engaged, but there were also the students who weren't, you know. So I'm sitting here, I look at y'all, and I'm happy because most of you are engaged, but then I know a few of you I know I've lost you, you know. You're tired, you just yeah, so okay. I just thought I'd share that with you. I do have some sort of association with what you're going through right now. Yeah, it's weird. We evaluate, which I think you should just evaluate math people, just only because the government, from what she could have been saying, it could have been complete BS. I would have not known, you know. I wouldn't have been able to know if what she was saying was correct. So I think you should be able to have that knowledge. Yeah. Yeah. It's a long hour, 15 minutes, isn't it? And a lot of it's PowerPoints that you've already have access to online, right? Yeah. Take it online. Okay, let's get back to this. This is exciting stuff. This isn't government. This is exciting. All right, so I've turned this into a difference of squares. My a here is 4, my b here is x squared, isn't it? So the formula, just in case you've forgotten, the formula is it'll turn into a plus b times a minus b, right? It's on your formula sheet. So what I'm going to do is I'm going to take this in parentheses. I'm going to rewrite it with these two sets of parentheses using a is 4 and b is x squared, right? And I still have that 5 that my GCF was outside. Here are my two sets of parentheses. A plus b. Four plus x squared. Okay. A minus b. 4 minus x squared. And you start to draw your box and you go, wait a minute, hold on. Step 5 is always to check to make sure that what I have cannot be broken down further. Inside this parentheses, I have two terms, right? So I'm looking at my formulas and I'm saying, is this a difference of squares? No, because it's not a minus sign. Is it difference of cubes? No. Is it a sum of squares? It is. It's 2 squared and x squared, isn't it? Is there a formula for sum of squares on here? What does it say on here for sum of squares? No, but look at the table. What does it say at the top of that table? Prime. Remember, there was no formula for this? This does not factor. That does not break down. This one, however, is a difference of 2 squares. Isn't it? Because it has a minus between them. So what I need to do is step to the side again. I need to write down 4 minus x squared, right? I need to see if I can rewrite that as something squared minus something squared again. I take it that that sigh was a sigh of excitement. Was that what that was? Netta doesn't realize she did that. Was that? Yes. This is exciting. Okay, so what is 4? It's what squared? 2. And then x squared is x squared. So we have a new a and b, right? This is totally separated from what we did already. This is a new a and b, a new application of the formula again. Understand? So we're going to go, it'll be a plus b times a minus b in parentheses. So this right here. But A for us is 2 now, and B is X. I do not touch the 5. I do not touch the 4 plus X squared. I do write 2 sets of parentheses. 2 plus X, 2 minus X. Do you all think it's inhumane to shoot a dog with a paintball gun? A stray dog? I no, my neighbor, he has some problems with stray dogs messing with his dog and What? Oh, I'm sorry. Well, everyone, my brain is usually off in some other place when I'm up here, and so, I'm just curious because I was thinking, like, if you do that, like, someone's probably going to wonder why their dog has orange paint on it, and probably figure out where you live. Just, yeah, yeah. I heard they hurt. I haven't done it, but no, not yet. I know. All right, so on this, we're here now, right? We know the first 2 don't factor. Look at these in here. Are we done or not? These are not squared or cubed or anything anymore, right? We call these linear factors, meaning that the highest power that we see is 1. As soon as you're there, you're pretty much finished. Yes. So now you can sigh. We're done. All right. One more. And that'll at least get you ready for your homework assignment. We're going to take this section. We're going to do homework today is only going to cover about half of the homework that I'm going to give you for this section. Yeah, I'm going to give you about half the homework out of this section, then when we come back, we'll do the other half. All right, so here we go. 3 RT squared plus ST squared minus 21RY minus 7SY. They're all S's. Yep, there's no 5s up there. Good question. I do have problems with my S's and 5s are probably the worst letters and numbers that I have because they look too much the same. Yeah, well, I thought it was small enough, but it's okay. I think we're all on the same page here. All right, everyone. How about GCF? Okay, so you did think about that first, though, right? So GCF, I have some T's in these 2, but there's no T's in here, right? I have an R here and an R here, but not everywhere. I have an S here, but not everywhere. I have a Y and a Y here, but not everywhere. Don't have a number that goes into all of them. So I don't have a GCF. But I have 4 terms. 4 terms, you split it, and you go GCF out of the first 2. Just T squared, right? Be careful with your language on that. I know you know what you're supposed to, but if you say 2T, 2T is that, right? T squared is this. So 2 different things. You just have to be careful. I know you meant this, but if you say 2T, that's really what it means. It's okay. Now what's left? 3R plus S. Now grouping, the way it's worked for us is that we have to be able to get that to match. So let me put it over here. That is an S. And how can I turn 3R into negative 21 RY? What am I missing here? I need a negative 7, and then I need the Y, don't I? Now let's just double check that when we do negative 7Y over here to the S, we get negative 7 SY. We do. So it's good. Since they match, I pull that out front, 3R plus S. And then the other parentheses, what goes in there? T squared minus 7Y. Well, I'm done if these don't factor. So my first factor here has two terms, but neither thing is squared or cubed, right? So I'm okay here. Over here, though, I have a minus and I have a t squared, don't I? But we'll look at the 7y. 7 is not a perfect square, right? And y is not squared. So even though the t is squared, I'm not going to be able to rewrite 7y as something squared. What if it was 9y? Well, I could rewrite the 9, but I couldn't rewrite the y. So it still wouldn't be able to break down. What if it was 9y squared? Then I could. All right, so I'm done. All right, so here's what we are going to do. I'm going to give you the homework assignment. I want you to begin working on it for the last 15 minutes of class. All right, it's going to be page 434. We're going to do problems 11, 13, well, hold on, 27, 29, 31, 33, 35. Okay, that's good. 11 through 47 odd. So that's somewhere in the neighborhood of like 18 problems or so. I will give you the advice to make sure that you check in the back of the book for your answers. A few of these are prime, meaning they don't factor at all, nothing, right? So if you get to that point where you're like, what's going on here? So I'm going to do a quiz grade today on your, let's say the first, you got to get through at least the first 3 of these in the next 12 minutes. You do it with your homework, but I'm going to come by and look at it. I just want to make sure for the next 12 minutes you are trying to do some problems, all right? Yeah, I don't mind if you work together. Let's stop the recording. Anybody need a copy of the book? Y'all do it at that table?